So today we'll be talking about research questions, null hypotheses, and alternative test, or as I like to refer to them as directional hypotheses. All research begins with a question that you're aiming to answer, and this would be the format that you use for developing that research question, which is, does independent variable correlate with dependent variable? Now, the research question will generally be the title of your paper, so this way whoever chooses to access your paper will know exactly what it is that you're studying. So your research question, does fill in the blank independent variable correlate with fill in the blank dependent variable? Now, a quick definition, an independent variable is any variable that you either control or you control for the purpose of this particular experiment. So for example, independent variables that I'm able to control would be temperature in a classroom, or lighting in a classroom, right? I can directly control, I can manipulate these variables if I were to study, let's say, the dependent variable of student performance. Now, the second part of that definition with independent variables, when it comes to variables that I can control for, examples of that would be, let's say, biological sex, which I cannot control other people's biological sex. However, I can control for their biological sex by grouping and sorting appropriately based on biological sex. Same thing with age. Age is another independent variable that I can control for, but I cannot control, meaning I cannot control someone's age, but I can control for their age by grouping them and sorting them in categories of, let's say, 20 to 30, 30 to 40, 40 to 50, so on and so forth. So in any research experiment, you have all the freedom in the world as far as developing your research question, what your null hypothesis and your directional hypothesis will be. There's no limit to that. That's where that academic freedom comes into play. There's nothing wrong with choosing one independent variable and another dependent variable and then flip-flopping between the two for your next experiment. So it's important to understand that there's no correct dependent variable and no correct independent variable. Either can be any. So for the purpose of this example, I decided to go with sleep and exercise as my variables. Now notice I didn't say independent variable or dependent variable. Sleep and exercise, just in summary, will be my variables for this particular video. I'm going to interchange between sleep and exercise, and I'm hoping that it'll make sense as to how you also have the academic freedom of choosing what to study and what to manipulate. Now, when I say what to study, I'm talking about the dependent variable. The dependent variable is sometimes also called the outcome variable. So if you're studying, let's say I'm studying sleep, right? Okay. Sleep is the subject that I'm studying, and I'm manipulating exercise. So I'm just going to fill that in right here, exercise. So here, exercise is my independent variable, sleep is my dependent variable. So my question is, does exercise correlate with sleep? Now, it's not to say the word correlate is different from the word impact, which is terminology you may have been using thus far. Impact suggests that one comes before the other, as in, if I were to say, does exercise impact sleep, which would be a good way of introducing the research question and the hypotheses, ideas to concepts to students, but then we advance it to correlate. But with impact, it gives the impression that one comes before the other. So if I were to write, does exercise impact sleep, you would automatically think of exercise coming first, and then that impacting sleep or coming after that. So here, when we say, does exercise correlate with sleep, we acknowledge right away that exercise, being the independent variable, is the variable that we are manipulating. Now, it happens to be a variable that we can control, so let's assume that that's the variable that we're going to be influencing, we're going to be controlling, and then we're going to be studying the variable of sleep, which we're not going to be manipulating, we're not going to be controlling, and we're not going to be controlling for. right? For the purpose of this particular experiment, we realize that, or rather we acknowledge that exercise is the independent variable and sleep is the dependent variable, which means exercise is the variable that we are controlling or controlling for, manipulating, and sleep is the variable that we are studying. It's the outcome variable, a dependent variable. So filling in the blanks with the null hypothesis, we'll just do it this way. So the null hypothesis would be independent variable does not correlate with dependent variable. So here we've chosen exercise to be our independent variable, and we've chosen sleep to be our dependent variable. So you might be saying, well, the null hypothesis doesn't make sense. All the literature suggests that exercise does indeed correlate with sleep, either positively or negatively, depending on when you're exercising or even what article you're reviewing. Exercise does indeed correlate with sleep. The answer to that complaint, if you want to call it that, would be that it just simply doesn't matter. A null hypothesis is stated as a null hypothesis, which is this, you're filling in the blanks here, regardless of what you might think is true. Remember, when we say the word hypothesis, you may have thought of it as something that you are aiming to prove right. That's not the case at all. Many courses might teach the hypothesis as though it's some sort of sales pitch, that if you find that your hypothesis is found to be untrue or invalid, then somehow that lessens the value of your experiment. Nothing could be further from the truth. Again, nothing could be further from the truth. A hypothesis is not a sales pitch. A hypothesis is simply a statement that you are trying to find the validity of, the accuracy of. Now, if you find that the hypothesis that you've written out is in fact invalid based on the research that you thereafter conduct, it's just as publishable and it's just as high of a quality. You do not have to have your hypothesis validated in order for your study to be of value. Okay? So again, a hypothesis is not a sales pitch. So if you disagree with the statement, even if literature disagrees with the statement, exercise does not correlate with sleep, it simply doesn't matter because that's how a null hypothesis is stated. Here, with the alternative hypothesis, we have a couple of different options here as far as how we're going to be stating and filling in the blanks. Now, if your variable is either interval or scale, meaning numerically measured, you would choose option 1. So here you can say as exercise increases or decreases, sleep increases or decreases. If your independent variable for this particular study is not numerical, meaning it's categorical, which would fall into the categories of nominal or ordinal, then you would have to choose a particular category within that independent variable and go with choice 2 here, and then you'd still fill in the blank with the dependent variable. So an example here would be mode of exercise, perhaps. Maybe you're not doing exercise in regards to how much exercise, rather running versus lifting weights. Maybe that's how you've defined your independent variable here. So in the first category where we have exercise as a numerical variable, we can just write as exercise increases, sleep then. Let's say sleep decreases. Okay. Now you can choose increases or decreases for either or. You're not confined to anything in that regard as far as well, this is, it should be increase or increase decrease or decrease or decrease increase. You pick whatever choice you'd like out of the 4 options. So here I've chosen as exercise increases, sleep decreases. Now if I've gone in the direction of defining exercise in the way of a numerical variable, this would be my choice. However, If I've chosen to define exercise as a non-numeric variable, as a categorical variable in the nominal or ordinal scale, then I might fill out the second option here for the directional hypothesis, which would be running increases. Well, let's go with decreases. Why not? Right? Decreases sleep. Running decreases sleep. Oh, sorry about that. Let me just go back here and just give you as solid a visual as possible. So here I have one way. Option one is as exercise increases, sleep decreases. This is where I've defined exercise as a numeric variable. In the second option, I've defined exercise as essentially a nominal variable, right? So here I've chosen to go with running as opposed to weightlifting, as opposed to cross training or anything like CrossFit or anything like that. So here I've chosen to define exercise as a categorical variable, in which case I've chosen one of the options from my independent variable. Again, you have the academic freedom to choose how your variables are defined. And in many cases, students are fearful of that because it essentially is a free-for-all. You have the academic freedom to decide, and sometimes we can get uncomfortable defining variables in the ways that we can, and without us being prompted to do one thing or the other. So you may have noticed that as exercise increases, sleep decreases. That doesn't sound like a factual statement. It sounds as though as exercise increases, obviously you get more tired and you're healthier, so your sleep should do better. But at the same time, keep in mind that your hypothesis is not a sales pitch. It's not a sales pitch. So you can have a hypothesis that in fact disagrees with the literature just for the sake of disagreeing with the literature and you seeing whether or not the literature is indeed validated by having a directional hypothesis that contradicts it. You're welcome to have as exercise increases, sleep increases as well. It's all up to you. You're not confined to any particular phrasing of the directional hypothesis. Same thing with running decreases sleep. Running should increase at least the quality of sleep, shouldn't it? That's what most literature suggests happens. But as a hypothesis not being a sales pitch, you are welcome to choose a hypothesis that contradicts literature, that, even and this is truly a fact, you can choose a hypothesis that contradicts common sense, which, this essentially does. So here we've done exercise as the independent variable. So my question here is, does exercise frequency, right, if I'm doing numeric exercise as a numeric variable, does exercise frequency correlate with sleep is my question. Here, I would say exercise does not correlate with sleep. Here, again, I'm thinking of exercise frequency. Now, if I'm speaking of exercise in the context of frequency, then I would go with option one as far as my directional hypothesis, which would be as exercise frequency increases, sleep decreases. You don't have to write out the word frequency, obviously. But if I've chosen to go in a categorical route, does exercise, as in different kinds of exercise, running versus CrossFit versus weightlifting, correlate with sleep, I'm able to do that as well, with my null hypothesis being exercise modality, let's call it that, does not correlate with sleep. Null hypothesis is still filled out the same kind of way, except if we were to go in the categorical route, we wouldn't choose the first option, we would choose the second option. Here we've chosen running decreases sleep. And by doing this, you're essentially saying that running decreases sleep more so than, let's say, weightlifting or CrossFit. Okay, so that's one example as far as how we're phrasing the research question, the null hypothesis and the directional hypothesis, with exercise being the independent variable. Now, as I mentioned earlier in the video, you can choose to have any variable as your independent variable, or any variable as your dependent variable. So what would happen if I were to have as my independent variable sleep? and my dependent variable as exercise. So here I would phrase does sleep correlate with exercise, right? Now you notice it's the exact opposite of what I had earlier. Earlier I had does exercise correlate with sleep. Here I have does sleep correlate with exercise. Here you can automatically assume that since sleep is the independent variable, this is the variable, sleep is the variable that I am either controlling or controlling for, manipulating. Meaning I'm forcing myself to get 8 hours of sleep, 10 hours of sleep, 6 hours of sleep, correlating with exercise, right? With exercise. Let's say it's exercise frequency, exercise quality. It really doesn't matter as far as the dependent variable, because that's the variable that you're studying, and whatever happens based on the variable that you're manipulating happens. So here you have to be aware that sleep is the variable that you are manipulating, controlling, or controlling for as the independent variable, and exercise is a variable that you are intentionally not controlling for or manipulating in any kind of way. You're only manipulating sleep to see how it affects or impacts or how it correlates with exercise. So here we're going to just fill in the blanks one more time. Null hypothesis is phrased as the independent variable does not correlate with the dependent variable. So here we've switched it up. We have the independent variable as sleep, right? Sleep does not correlate with exercise. And that's my null hypothesis right there. Now again, it might, most literature as I've reviewed it, suggests that sleep and exercise are very closely correlated, but that does not matter. Hypothesis, your hypothesis, my hypothesis, all hypotheses are never sales pitches. They're just statements that we're trying to prove wrong or prove right. Rather, we're trying to see whether or not they are indeed right or wrong, and there's no ego attached to it. If your hypothesis, either null or directional hypothesis, is shown to be wrong, perfectly fine. Your study is just as high a quality as it would be if your hypothesis was shown to be correct. So here I've switched it up. My research question is, does sleep correlate with exercise? And my null hypothesis is sleep does not correlate with exercise. I'm just filling in the blanks here. Excuse me. So for my directional hypothesis or my alternative or test hypothesis, if I were calculating sleep numerically, now there is a way to calculate sleep categorically, which I'll get into in just a moment, but most people think of sleep as hours of sleep, in which case that's perfectly fine. We'd go with option 1 as sleep. Oh, sorry about that. As sleep decreases, let's go with that as an example. As sleep decreases, exercise increases. Okay. And then just for, I'm not even giving this much thought as far as what my hypothesis is. My ego is not connected to my hypothesis. This is not a sales pitch. I'm not trying to sell anything. I'm just trying to see whether or not something is true. So here, as a numeric variable, I've decided to go with as sleep decreases, exercise increases. So let's just go back one more time here. We're thinking of the independent variable of sleep as hours of sleep. So here you have the research question, does sleep, as in hours of sleep, correlate with exercise? Then my null hypothesis, again, would be sleep in hours does not correlate with exercise. And then I would choose option 1 because I've chosen to define sleep as a numeric variable. As sleep decreases, hours of sleep decreases, exercise then increases, which that, again, does not make much sense from a literature review standpoint. We already know that the more you sleep, the more refreshed you are, the more likely you are to have the energy to exercise, but once more, it does not matter. If this hypothesis is shown to be invalid, it's still perfectly fine. If this hypothesis is shown to be valid, just as publishable, just as good of a work. Now, if we were to define sleep as quality of sleep, let's say we had it on at a categorical level and we were to use an ordinal scale to determine that. So let's say the three choices would be good, neutral, bad. Does sleep correlate with exercise? Here we're talking about quality of sleep correlating with exercise. So here the research question would be, does sleep, remember quality and not hours, correlate with exercise? That would be our research question. Our null hypothesis would be sleep, as in the quality of sleep, does not correlate with exercise, our dependent variable. And since we've chosen to go with sleep as an ordinal variable as opposed to a numeric variable, which would be a ratio variable, we're going to go with the second option as far as the directional hypothesis, because we'd have to choose one of the choices within the sleep category. Let's say high quality or good quality sleep. Good quality sleep, let's say, increases exercise. Okay. So here you see that we've chosen to define sleep not as a numeric variable, as in hours of sleep, rather an ordinal variable, not as a scale, not as a ratio variable, but rather as a ordinal categorical variable, where it states good quality sleep, which is, we have the quality of sleep measured as good, neutral, or bad. Good quality sleep increases exercise. We've chosen to go with this particular hypothesis, directional hypothesis, only when we've defined the independent variable in such a way as though it's not numeric, rather categorical. Here we have stated good quality sleep increases exercise, which, based on the literature, sounds about right. All right, so that'll be it for this video. I'm going to be linking this file in the description, so this way you can access it and play around with it yourself. Feel free to pause, replay, and yeah, thank you.